This lecture is going to go over the basics of chemical reactions. So you won't need a periodic table, just make sure that you do have your objective sheet out because we will hit some of those objectives in this lecture. Alright, so chemical reactions. You are going to see RXN written quite a few times. That's just an abbreviation for the word reaction. Throughout the rest of this video and throughout the rest of the course, when I write reaction, I'm just going to write it like that. So just know that that's what that means. If you want to write it that way, fine. If you would prefer to write it out the entire term reaction, whatever works for you is fine. Just make sure that you're aware of what that is. So what is a chemical reaction? So it's when we have combinations of elements and or ions, so not just single elements. So you might see a sulfate, you might see a nitrate, that's not going away. It's when they come together and they rearrange themselves to form new substances. So we start out with some things, they rearrange, and then we end with something else. Okay? We're going to do a lot of examples of these, so you'll get plenty of practice. But first, we want to talk about what the evidence of an actual chemical reaction is. How do we know that a chemical reaction actually occurred? So the first thing is if we have a change in color. So you can think about something we did recently where color was changed when we did the emission spectrums, when you lit your little sticks on fire from the potassium chloride or the copper chloride. When you did those, what happened? You had a color change because a chemical reaction was happening. So the next thing, a temperature change. If something gets really, really hot or something gets really, really cold, if your temperature changes, a chemical reaction is happening. Formation of gas. So if something starts bubbling. So think about if you've ever got a cut and someone's put hydrogen peroxide, that stuff in that brown bottle, on your leg and it starts to bubble. That is a chemical reaction that is occurring, okay? Formation of a solid. So if you mix two things together and then suddenly you have a solid in there, that is a chemical reaction. We have a new substance. And an important word for you to keep in mind or to know is this word precipitate. A precipitate is a solid that comes from a chemical reaction occurring. It's a solid that came as a result of that reaction. That's an important word for you to keep in mind because you're going to see that later and you want to know that that means that it's a solid. And the last thing is the emission of light. So, back to what we just did. We just did a lab that had the emission of light, and you saw that example there. All right, but why do chemical reactions occur? So we know when they occur, but why? They occur so we can form solids. These are going to look very familiar. They occur to form water, to form gas, and a very important one, which we'll see a lot of, is the exchange of electrons. So chemical reactions are going to occur so electrons can be exchanged from one atom or one ion to another one. Whether they're being shared, whether they're being moved, that's all each in its own, but exchanging of electrons. All right, chemical equations. So we know what a chemical reaction is, but now we're going to talk about equations. So up to this point, anytime you've heard the word equation, you're probably thinking math class. Now, these equations are a little bit different, but they do the same thing. They're going to show the process of what is happening. So they're a way to display what is occurring within a reaction. They're showing us what's actually going on. So things that we have within our equation. We have reactants. So that's what we're starting with. That is what's going to react together in order for us to start our equation. So your reactants are the things that you start with. Then we have products. That's what you end with. So this is what is being produced. So when you hear that word produced, you probably think, oh, something's being made. Same thing here. We have reactants that are reacting together to produce our products. So then we have these states. These are the states of matter. So we know some of these already. We have a solid. We represent this by a little s. We have a liquid. We represent this by a lowercase l. We have gas. We represent this by a lowercase g. And then the last one, which you probably have not seen or used before, is called aqueous. So when you see that prefix, the AQU here, if you've taken Spanish or even French, you're probably thinking water. Okay, so that is the correct thing. We represent that by AQ. That just means that that substance has been dissolved in water. So anytime you see something like a solution, so if you see the word solution, you should be thinking that it is aqueous as well. And the last thing we have in a chemical equation is an arrow. This arrow shows us the direction of the reaction, and it also separates our products from our reactants together. Okay, if you don't have all this, pause this because I'm going to move on. All right, so here's an example of a chemical equation. So let's take a look at the things that we have here. We have hydrogen gas plus oxygen gas gives us liquid water. Okay, so things to go over. In the red here, these are, I want to change that to red. These are the reactants. Okay, which means that over here, the purple is our product. Now, you may have one product, you may have three products. It all depends on what the reaction is. Okay, so don't be nervous if you're like, why do I have two products? Why do I have one? It all depends on what the reaction is and what's happening. Okay, so then here we have our states. We have gases and gases forming a liquid. So let's note that there. Okay. And then we also have this number here. And we're going to talk about this number here in another video. But this is our coefficient. FF. Let's fix this here. So this is a number that we're going to add because we want our equation to be balanced. We'll talk about balancing equations in another lecture. But just know that this is a coefficient, and then these numbers here are the subscripts. And you're very familiar with subscripts for when you did the unit on naming. So ways that you're going to see the equations. You could see it in equation form. It's already written out for you. So we have methane gas plus oxygen plus carbon dioxide gas gives you water. That's one way. Another way is you'll see equations written in word form. Magnesium metal is dropped into a solution of sulfuric acid to produce aqueous magnesium sulfate and hydrogen gas. That sounds like a lot, and we're going to go over how to write this out in another video. But just know you've been exposed to all this stuff before. You know what magnesium is. You know what sulfuric acid is. You know how to write out magnesium sulfate, and you know what hydrogen gas is. So really all it is putting those things into the formulas that you know they are. Taking the words and making the formulas. Okay, so that is the end of this lecture. You are going to want to watch the next one before you attempt any practice problems. This is just kind of your introduction here.